Hi everyone, this is Infinity YouTube channel. Please remember to like, subscribe, and share. So today we are going to deal with parameter estimation. So in parameter estimation, is basically a procedure by which numerical values are assigned to a population parameter based on the information collected from the sample. So in this population parameter, we are going to look at two types of in this parameter estimation, we are going to look at two types of estimates, which are the point estimate and the interval estimate. So on the point estimate is basically when an estimate of a population parameter is given by a single number. So when you are solving and the population parameter is being given by a single number, then you know that you are dealing with a point estimate. Then for the interval estimate, of course, as its name implies, it's an interval between two variables. So in this interval estimate, when an estimate of a population parameter is given by two numbers between which the parameter may be considered to lie, then we say we are dealing with an interval estimate. So in this population parameter, we shall look at our procedures on how to, of course, estimate. Okay, the procedures for estimation. Now, when you are trying to estimate, one of the things you should consider is you have to select the sample that you want to estimate, right? So when you select the sample, you have to collect the required information from the numbers of the samples that you want to deal with. Then the third thing you have to do is you have to find the value of the sample statistics. Of course, you have to do that by calculation. Then the last you have to do is to assign values to the corresponding population parameters which you've collected. Now, in this population parameter, in this parameter estimation, so the confidence level is determined by 1 minus alpha times 100%. But before we deal with the confidence level, let's look at the formula for the parameter estimation. So the formula for the parameter estimation is given by mu equals by x plus or minus z sigma over root of n. So where this mu is called the population mean, and of course by x is called sample mean, z is called the critical value, and sigma is called the standard deviation. Then the last but not the least is our n, which is the sample size. So before we go ahead to solve an example on this parameter estimation, so I was trying to explain the confidence level. So when you are asked to determine the confidence level is expressed as 1 minus alpha multiplied by 100%. So this is how the confidence level is being written. So we express this confidence level as a probability. So remember, since we express this as a probability, so it becomes, since we express it as a probability, so it becomes 1 minus alpha. So since it becomes 1 minus alpha, this alpha here is called the significance level. The alpha is called the significant level of the population parameter. So whereas the 1 minus alpha as a whole is called the confidence coefficient. So we call this the confidence coefficient. So all right, now let's solve equation to see how we can utilize the formula that we've written so far. Okay, so I have a question here. So from this question, it says that the quality control manager of an energy bulb factory in Nigeria wants to find the mean life of some electric bulbs in the company's store. The standard deviation was found to be 120 hours. So let's go with that. So solution. So they said that the standard deviation, which is sigma, is equals to 120 hours. Then let's continue. Then they said a random sampling of 81 bulbs indicated a sample mean life of 360 hours. So that means the sample mean here is 360 hours. Then bar x is equals to 360 hours. Then the next we have to look at is the sample size. Of course, you can see that it is 81 in number. Okay, yeah, 81 in number. So the sample size now is 81 in number. So that means by x is equals to 81 hours. So from the information, according to the question, from the information that we should construct a 95% confidence interval estimate of the population mean life of the bulb. So what we want to calculate for is the population mean life. So, and from the parameters I gave you earlier, the population mean here is the mean. So we are going to solve for this guy. Now so that means the mean now, as I said, is equals to bar x plus or minus z sigma over root of n. So where our bar x, of course, is 360 hours. So that means mu is equals to 360 plus or minus. Now let us determine our z from, let's get the value of this z. So from the equation, the z was given as, they say that we should construct a 95% confidence interval. So this is what we are going to use to calculate for our z. So it's 95% confidence. So we know that the full confidence is actually 100%. So what we do is that we are going to subtract 100% from 95%. So if you subtract 100% from 95%, we'll be left with only 5%. Now this 5%, of course, 5% is equal to 5 over 100, which is equals to 0.05. All right. So since the 5% is 0.05, so the next thing you have to do is looking at the equation, we are going to find interval, right? So since it's an interval that we want to look at, that means we are looking at two variables, as I explained earlier. So since we are looking at two variables, so what we do is to divide this value by 2, because we are looking at intervals. So when we divide this value by 2, that means 0.05 divided by 2 will give us 0.025 as the value. So this value is what you are going to use to search for your z, the value of your z. So you can say that z alpha over 2 is equals to 0.025. So from the table I have here, what I have here is actually a t distribution table. So but remember, what we need to find, of course, is our z table. So but you can still use this t distribution table to solve for that. So when dealing with this t distribution table, of course, look at this value here, df, which is the degree of freedom. So the value that we have here, the value of the n that we have here was actually So the value of the n that we have here should be n. The value of n that we have here was actually 81 hours. So now looking at this table now, we won't see 81 on the table, right? The table ends at 75. Well, if you look below that, you see infinite. That means the 81 falls on the infinite. So what we do is that we look at the top side of this table. So we look at the top side of this table. We are going to look out for the value that we divided, which is 0.025. So this is our 0.025. So we trace it down. We trace it down up to the infinite. Of course, it meets at 1.96. So since it meets at 1.96, that means our z alpha over 2 is equals to 1.96. So we can substitute that here, and we have 1.96 into 1.96 into our z. Of course, our sigma here is from what we've calculated. Our sigma here is 120. So we have 120 divided by our n here is 81. Our n is 81. So what we have is root of 81. So if I should break further, I have mu equals 360 plus or minus 1.96 times 120 divided by 9, because the root of 81 is 9. So we can express this into, since it's plus or minus, so that means the plus will be the upper value and the minus will be the lower value. So for the upper value now, we have mu, which is now equal to 360 plus 1.96 times 120 over 9. Now if you should press that in your calculator, so I believe you should be having 386.18. Okay, should be having 386.18 times 120 divided by 9. So we have 386.13 from my calculator here. So now the next is to look for our lower value. So for our lower value now, the lower value becomes the mu, which is now equals to 360 minus 1.96 times 120 divided by 9. So if you should subtract this value now, so what we have is 333.86. So okay, approximately 333.87. So since we have our upper and our lower values as these numbers, so we can express these as the lower number first, that is 333.87 is less than or equal to mu, which is less than or equal to the higher value, which is 386.13. So this is basically the answer to the first question. So and then when you've written this value, you can add up to your answer by saying that the implication of this result is that the population life of the 91% confidence lies between these two values. So judging from what we solved here, is this a point estimate or is it an interval estimate? So since it's an estimation between two values, that means it's an interval estimate. So the next we want to find from our equation is The question says, the B part now, should explain, the B part says that we should explain the implication of the manufacturer of the bulbs, indicating an average life of 40 hours on a bulb, on the bulb. So that we should explain the implication of having a different mean. That is what it means. That we should change the mean now. That when we change the mean, then we should determine when we change the mean, that what will happen to this what's going to happen to this interval which we've solved so far. So what we do is that you can actually impute this mean, you can impute this mean back by changing the original mean, and then you look at the intervals and see what you've got. So by doing that, we can say that mu now, is equal to, so since the bar x has been changed to from 360 to 40, hours, so we can just say is equals to 360 is equals to 40 plus or minus the same values that we've gotten, 1.96 times 120 divided by 9. So for our upper and our lower values, we have, for the upper and the lower value, we have that for the upper now, we have that mu is equals to 40 plus 1.96 times 120 divided by 9. So if you should get that from your calculator, we have, 66.13. Then for our lower value, for the lower now, we have that the mu should be equal to 40 minus 1.96 times 120 divided by 9. So if you should subtract this value, we are going to have, from my calculator, I have 13.87 approximately, 13.87. So when you have this value, judging from the original value that we had, which lie, okay, let me write the interval now. This interval is 13.87, which is greater than or equal to, so less than or equal to mu, which is also less than or equal to 66.13. So looking at this interval and the previous one that we solved, so we can see that the implication now is from when we observe our average mean life, okay, so when we observe the average mean life when it was 360 hours, if the manufacturer gives out a bulb at a mean life of 40 hours, right? So what will happen is that, of course, there is going to be a significant change in the population mean life. So as you can see, there was a difference in the population mean life. So conclusively, we can say that the observed sample mean is 360 hours. And then, but if the manufacturer gives out the bulb at a mean life of 40 hours, then there's going to be a significant deviation, okay, a significant deviation from the population mean life. So judging at what we have here, there was a significant deviation from the population mean life. So that's how to answer the B part of the equation. Now for the C part of the equation, so the C part says that is the population of the energy bulbs normally distributed? Is it normally distributed? So of course you can say that the population is normally distributed. So since what can you do to in order to know that if your population is normally distributed? So what you basically do on the C part now is that just from what we had earlier on, add up the two mean and divide it by 2. So of course it should give us 360. So if you should add up the two mean and divide it by 2, and it gives us 360 hours, hence our population mean life was evenly distributed. So let's add it up. So we have 333.87. So we have 333.87 plus 386.13, 386.13 divided by 2. So this gives me 333.87 plus 386.13. So this gives me 720 divided by 2. So as you can see, it is 360 hours. So hence, what we calculated so far is evenly distributed. This is evenly distributed. Evenly distributed. Now, the last but not the least on our table, on our question is, they said, suppose the standard deviation changes to 90 hours. What will your answer be in A and B? So this is actually also very straightforward. So what you do here is that just change the standard deviation, because the original standard deviation that we solved with was 120. So we are going to change the standard deviation for the first interval and change the standard deviation for the second interval. So let's do that. So on the D part now, so what we had is mu equals 360, right? Plus or minus. That what we had is 360 plus or minus 1.96 multiplied by, but this time we are not going to use a standard deviation of 120 according to the question. So we are going to use a standard deviation of 90 hours. So that means what we'll be working with here is 90, but every other stuffs remain the same. So that is 90 divided by 9. So that's what we have. So of course we are going to do for our upper and for our lower values. So for our upper value first, so what we have is mu equals 360 plus 1.96 times 90 divided by 9. So 1.96 times 90 divided by 9. So what we have is it should give us 379.6, right? 379.6. Okay. 90 divided by 9. So 379.6. Now for our lower value now, for the lower value, we have mu equals 360 minus 1.96 times 90 over 9. Of course, if you should get your lower value, you are going to have 340.4. So we can decide to rewrite these in interval form as the lower value first, that is 340.4 is less than or equal to mu, which is less than or equal to 379.6. So from what you can see so far, we can say that at 95% confidence level, that the manager is very sure now, double sure, that the Bobs has an average mean life between 340.4 hours and 379.6 hours. So that is how we assess questions like this. So of course, sometimes as well, I used the T distribution table to determine these the critical values, that is the Z, for what I've solved so far. So you can also use your Z table to do that. So I hope this video was helpful. Please remember to like, subscribe, and share. Thank you.